Hi, so this session is on understanding how to identify the turning point and also locating the turning point. Now, if we have our basic parabola, we know our basic parabola, its turning point, so we've got y and x, passes through the origin, which also happens to be the x-intercept when x is 0, the y-intercept when y is 0, and so our turning point is 0 and 0. When we start adding things to our basic parabola, for example, if I have y equals x squared plus 2, this is where our basic parabola now shifts up 2 units. So the y values, or the y value of the turning point changes. So if 2 is just here, positive 2, my basic parabola will move up 2 units. And so this turning point is when x is 0 and y is 2. So x is still 0 at that turning point, but y is 2. When the x value of the turning point starts to change, that is where we notice a bracket, something like this. Y equals, and just so we have bracket x plus 5 squared. When we have an x plus 5, just say, and it's in brackets and squared, that's where our parabola moves left or right. Or the value of the x in our turning point is changing. So for example, if I had to quickly draw this, I know that it's the opposite of what we see, because if we solve this, x will equal negative 5. So I go to negative 5 on the x-axis, say there it is. So my turning point has moved 5 units to the left, and there's its new turning point. The y value for this turning point is still 0, so this turning point will be when x is negative 5 and y is 0. Because it's still on the x-axis, so y is 0. But when we have an equation where we add 2 changes, so now for this one, so with this equation, you can see the 2 changes that have happened. We now have the x plus 5 in brackets, and also the plus 2. Okay, so there's 2 changes that have happened, and that means our turning point will be different as well. So if I just draw another graph, and y and x, so if x is equal to negative 5, so there's negative 5, it's going to move to the left 5 units, but also go up 2 units. So imagine there's 2 there on our y-axis. That means there is our turning point. It's a minimum turning point because there's no negative out here, and that's what our parabola would look like. Okay, and so what is happening is our turning point is changing positions. Sometimes it can just move up or down, sometimes it can just move left or right, or it can do both, depending on what we add to this x squared. And that's what we mean by turning point form. So let's have a look at the turning point form. Now turning point form is the general turning point form that we can have, and instead of numbers we have just used algebra. So a can be a number, it can be 1 or anything else, h can be any number, and remember that could also be a positive, and k can be any number. Okay, so for example, the question we had before, we had y equals x plus 5 squared and then plus 2. Okay, so in this case a would be 1, h in this case is a positive 5, which we then solve to get a negative 5, and k for this example is a positive 2. So you keep in mind this a, this h, and k are just numbers. Now, to understand, to locate the turning point, there are 2 numbers that we have to look at. So I'll just write this off. And the 2 numbers that will give us our turning point are these ones. The one in the brackets, if we have any, and the one just on the outside. And remember, if we solve this, x is equal to negative 5. So for this equation, the turning point, because it's in turning point form, the turning point is when x is negative 5 and y is 2. And that's telling us it's going to move to the left 5 units and go up 2 units, or translate. And that's it. So we have to now be able to identify whether an equation is in turning point form or not, because sometimes they don't look like this. There are many ways we can write an equation, and sometimes it may not have brackets, but it's still in turning point form. So let's look at a few examples. Now, all of these, so how to know if an equation is in turning point form? Now, if we have a look at all these equations, these are actually all in turning point form, but they don't look the same, do they? And some of these don't look like the formula we had before. Now, this is a basic linear equation, and we know to draw the a quadratic equation. To draw this, we know our turning point passes through the origin at 0. So x is 0 and y is 0. We can see this +2 will shift our parabola up 2 units, or translate it up 2 units, so it will have a different turning point. Now, the reason why these are all in turning point form, I'll show you two tests that you can do to see whether it is actually in turning point form or not. So to know if a quadratic equation is in turning point form, these are the 3 main points you need, and you'll have no problem. So the first one says that in an equation, there must be a squared somewhere, or a power 2. For example, y equals, it's supposed to change color, y equals x squared. Our basic parabola has a power 2. So far, it is in turning point form. The next thing we have to check is no x on its own. And what this means is, if I had, for example, y equals x squared plus, just say, I don't know, 2x. See how there's an x on its own, just sitting here? If there is that, then it is not in turning point form. So this equation here, even though we've got a squared, a power, unfortunately, it is not in turning point form. So to find a turning point for this one, we would have to do something like complete the square. So that is not in turning point form. So if we had, for example, y equals x squared plus 3, just say. Now, is this in turning point form according to these 2 points? Let's check. We must have a squared or a power 2. Yes, we do. And no x on its own. We have a number, a constant on its own, that +3, but there is no x. So this is actually in turning point form. And so is our basic parabola. This is also in turning point form. And the next point is sometimes h and k equals 0. So if you remember in that equation we had, the turning point formula or equation, sometimes h and k are 0. And I'll show you what I mean by that. So here's our turning point form equation. And I'm going to show you an example where h and k may be 0. And our basic parabola, we know the turning point is 0, 0. So we know that the h and the k, which are the values of our x and y, are 0 for our basic parabola. And I'll show you what I mean. This can be written as y equals bracket x plus 0 squared plus 0. Does this look like it's in the form of what we have up here? Yes, it does. We can see our h is 0. We can see our k is 0. And that's why the turning point is 0, 0. So for our next example, is this in turning point form? Well, first check, is there a squared? Yes, there is. Is there an x on its own? No, there isn't. So yes, this is in turning point form. So looking at this, we can see what the turning point is. And to have it in the actual turning point form, in that formula, we could write it like this. X squared can be written as x plus 0 squared plus 2. And we can see how the x value of our turning point, or h, from the formula is 0. So h is 0, and k, which is the y value of our turning point, is 2. So we would end up with, our turning point would be when x is 0 and y is 2. And that's it. We can actually then draw this graph quickly. So when x is 0, y is positive 2, there's our turning point. And we can also see that it's been, shifted up 2 units, so it's actually the same sort of thing. With this example, let's do our check. Is this in turning point form? Do you see a squared? Yes. Is there an x sitting somewhere on its own? No, there isn't. Yes, I know there's an x in the brackets, but because it's in the bracket and being squared, it's not an x on its own. So this is actually in turning point form. And to have the complete turning point form, we could have this. Our k is simply plus 0. Okay, so it does look like, ready, y equals, we've got a bracket x plus or minus h squared plus k. It's actually in this form. It's just that in this case, k was 0. And now, therefore, the turning point of this quadratic equation or parabola, turning point is when x is 3 and y is 0. And basically, when we have equations where they are a perfect square, we can see this equation is a perfect square, bracket and squared. These are the kind of graphs where the parabola will just touch the, so remember we solved this, so x is equal to, negative 3. We made a mistake. The turning point is actually negative 3, when x is negative 3. I forgot to solve this. So x plus 3, it's the opposite of what you see. X equals negative 3. So please correct that. So x is negative 3. The turning point just touches the x-axis and keeps going up. That's what we mean by a turning point that's a perfect square. The parabola just touches the x-axis at negative 3 and keeps going up. Okay, so this turning point is also the x-intercept because it just touches the intercept and goes back up. Okay, so I want you to write the turning point for this equation here. So remember, this 2 out here has nothing to do with the turning point. Okay, I forgot to put a squared here. We know a factor of 2 on the outside, this dilates our graph. So if it's larger than 1, we know our parabola is becoming more narrow. Okay, that's what that does. So the values we look at are h and k. So this 3, which is really in negative 3 when we solve it, and this is going to be our y value. So the turning point, okay, is when x is negative 3 and y is negative 10. And to quickly draw a rough sketch of that, the question asks you to then draw a rough sketch. Well, x is negative 3, y is negative 10, which will be down here. There's a turning point. Now, does our parabola have a maximum or minimum turning point? If we have a look here, it's a positive, so it will have a minimum turning point, slightly more narrow than our basic parabola, and there we go. Okay? And that's another thing to look out for. If there's a negative out here, we know it will be a maximum turning point. With our next equation, now, what's the turning point for this? Can we actually see what the turning point is? Let's have a look. We've got a squared. That's our first check. Yes, so far it's looking good. Is there an x on its own? Unfortunately, there is. There's a 3x here. So this is not in turning point form. So not in turning point form. So unfortunately, we cannot look at this and locate the turning point. That is where we now have to, a method we have learned is to complete the square. If we complete the square, we can then get it into turning point form. So let's complete the square for this one. Okay, we have b and square it and then add it on. So y equals x squared plus 3x. So we're going to have plus 9 over 4 minus 9 over 4 plus 10. I'll just squeeze it in. Now, you know how to complete the square, so you should be able to do this without watching me. So we have b and we squared it. So 3 squared is 9 over 4. We add it on, we subtract it, okay? And don't be scared of your fraction skills. And this here is now where we factorize it. So we have y equals, bracket, we're going to have x. There's a plus there, so plus, bracket, squared. And what goes here? The half of b. What was half of b? It was 3 over 2, or 3 divided by 2. And even if you have a fraction like this, 3 over 2 is just what? 1.5. So the turning point, the x value of our turning point, we can see it's going to be, opposite of plus is negative 1.5. Now, over here we've got, I'll just write it up here because it's squished in. We've got minus 9 over 4 plus 10. You can use your fraction skills. 10 is really over 1 and times by 4, or just chuck it in your calculator. So you can work that out. And you should have gotten 31 over 4. Now remember, yes, it's an improper fraction, but this is saying 7.25 and this is saying 1.5. So there's your turning point. This is in turning point form, okay? And we got this turning point form by completing the square. I know it was more tricky because we had fractions, but remember fractions are just numbers that have decimals. So finally, what I want you to do with these 4 questions is to identify whether they're in turning point form, and if they are, state the turning points. So try and do these first, and then we'll go through them now. So first one, is it in turning point form? Is there a squared? Yes. Is there an x on its own? No, there isn't. So this is in turning point form, and the value of my turning point has an x value of, if I solve this, x is -1, equal to -1. So the turning point for this one is when x is -1 and y is -2. Remember, the value of y is just what it is. It never changes. It's just this bit here that you solve it, so you get the opposite of what you see. Number 2, is it in turning point form? We've got a squared, yes, but unfortunately there's an x sitting here by itself. So it is not in turning point form, so we can't see what the turning point is. So not in turning point form. So we can't find a turning point. And we know to find a turning point, we can complete the square. All right, number 3, is this in turning point form? Let's have a look. Is there a squared? Yes. Is there an x on its own somewhere? Not in the brackets? No, there isn't. So yes, this is in turning point form. So the turning point is when x is, the opposite of +3 is -3. Sorry, it's -3. And y value, there's nothing there, so y value is 0. Done. And our fourth one, is this in turning point form? Well, no. As soon as you see a trinomial, x squared and an x on its own +2, unfortunately, it's not in turning point form because of this x. So it's not in turning point form, and the method you have learnt so far is to complete the square to then make it into turning point form. Okay, so hopefully you can understand now what we mean by turning point form and how to identify turning point form and then find the turning point. Thank you.